So lads, I'm going to look here at the 2023 question here. So I've started the setup here of it and did all the easy bits and indexed all the easy bits. So what you needed to notice here was like the parallel symbols here. So DA is parallel and A is up 60. So C joins to B, and then that's parallel, that's vertically up 60. So that there is point A, found A joins to D and to B. So that's the top view finished, and then you can project A back down, or front view finished. So A projects back down to here, so you can go ahead then and heavy in the rest of the top view. Like that. So that's everything drawn, indexed. Now the next thing you were asked there then is the dihedral angle between ABCD and BCEF. So BC is the line of intersection because that's on both of them. So I would recommend that you colour in BC. Just makes life easier, I think. So there's BC. Here's BC. So that's the line of intersection. So I want to get the true length of that. So just get the angle there. Set up next Y line and keep it close. I think you should keep it close. So we're going to project out B and C. So C is on the ground and B is at a height of 90. That there is the true length of the line of intersection, and again just to index it, so C is on the ground, B is up in the air, and finally now I want to look along that and get a point view of it. So I'm going to just go in the other direction now, not to go off the sheet. So I'm going to project up in this direction. So looking along BC, put a next Y line up here somewhere, and I'm projecting from here, so from the last XY line back. So BC is just this short distance back. And that's the same distance for B and C. So that there is point view of B and C. No, so we've got a point view of the line of intersection, but I need two other points as well. I need two other points on both planes. So it doesn't really matter what points you pick here, but I'm going to pick a point on the ground on both of them just to make life easy. So when I look across here at B and C, I'm going to pick two random points here now in a second. So I'm going to pick, now DC is on the ground. That DC line here is on the ground. So I could bring, well, I could bring D. Which is on the ground. And I could bring any other point here in line with it. So I'm just going to call this on the CF line here, I'm just going to call this point A, B, C, D, E, F. I'll just call that G, I think, on the ground. So that point G, I don't need to do this now because it's on the ground, but if I did want to bring it up there just to help you understand it, that is point G, which is on this plane, and I'm going to use point D that's on the other plane there. So that's both G and D here on the ground. And when I project them then along onto the point view of the line of intersection, when I bring them back up, now it just makes it easy when they're both on the same line. So again, I'm projecting from here, I'm projecting from this view, so it's from the last XY line back. So G is the same distance again as B and C was. And D is the farther away distance then. So that's D, B, C, and G. So my dihedral angle there is this. Okay, so that I'll just put in a symbol there to say that that's the dihedral angle there between the two planes. Now you could use any points and you could take more points, but you'll find that they'll all be on an extension of that. So we set up the planes, we found the dihedral angle. Now C, we look at part C there now next. So part C then it says P is a point on the edge BC. So BC is the true length edge that we've, or is the line of intersection, and we also have a true length of that. So P is a point on the edge BC that is located a true distance. Now the word true is important here, of 55 from B. Okay, so I would mark that over here on the true length, a distance of 55. So that there is point P. And draw the plan and elevation of the line DP. Okay, so what I got to do there then is bring it back and join it to D. So when I bring that back at whatever angle I projected, so P is here, and in the elevation, when I bring it up to the front view, so that's P on both of them. So P joins to D, but I'm going to do this now, I think in red actually there, just so you'll be able to see it. So P joins to D. And then the top view, P joins to D. So that's the line that they're talking about. Draw the plan elevation of DP. Determine and indicate the true length of DP. The true length of DP. Okay, now there's two ways of doing this, really. Three. Lots of ways of doing it. But I think I would do it by maybe rotation, because that's a pretty common way. Or I could take an auxiliary, or maybe I should look at doing both. But if I wanted to do it by an auxiliary, I would just set up an XY line up here, parallel, and project up. So this is doing it by an auxiliary. So P is up in the air, D is on the ground. So that's going to be D. And the height of P up in the air, or above the ground, above the XY line, is this. So that there is P, and that's the true length. Okay, that's done using an auxiliary, but some people prefer rotations. I kind of do myself. So if I wanted to do it by rotation, I would just take a horizontal line from D and rotate P. Up to here. So I'm going to call that P1. Going that up to the elevation, the height stays the same. So that there would be P1. And this here, I'll put it in dotted now, but that's another way of doing it. Like that is correct also. So that's also the true length shown there by rotation. And finally, determine the true angle between AB and BF. And I think I'll use a different colour here now, because colours make it easy. So between AB and BF. Now the easiest way to do this, might use is make a triangle. Always make a triangle out of it. So our triangle here is going to be AB and BF. So I'm going to make this green triangle here in the front view, and in the top view, so A to B, and B to F, and that green triangle now is what we're talking about in the front and top view here. So basically, like looking at the set square here, if you're seeing a true shape of the set square, sorry, you see the true angle of everything. So I just want to get the true shape of that green triangle. So what I would do is take a horizontal line anywhere. There's my horizontal line. I'm going to go to numbers for this bit now just to make it easier. So I took a horizontal line here. I'll just put H-O-R-I-Z for horizontal, giving me points 1, 2. I'm going to find them in top view. So 1 is on AB, and 2 is on BF, so this here is the horizontal line looking down on it. And if I look now, so that's a true length. If I look at that angle, I'm going to see a point view of it. So I think I'll bring it to the right here, a bit more space. So I'll project that out, set up an XY, or set up a XY line here. Now I know I'm going to put it on top of this here now. There's a lot going on here now, but just to keep it condensed. So I want to bring out the 3 corners of that green triangle. So here's A's on this line, and F. So I'm projecting from the plan, so I'm taking the heights from the elevation, so, or from the last view back. So F is here. You're better off to index as you go there to try and stop you from getting confused. A is here and B is this height. Okay, so this is B, F and A. So they should all be in a straight line, which it is, which is perfect. So that's an edge view of ABF. So one more step now to get the true shape of it is to take auxiliary of this. So I'm going to project out there again at 90 degrees to that. Now just to make sure it doesn't go too far away, I'd keep the XY line pretty close here now. Or I could even use the plane as the XY line if I wanted, but I think we'll get away with it. So, projecting from here, last XY line back. So F is this really close distance. So there's F. And B is further away. And finally A is the furthest. So there's A, and that is the true shape of the triangle ABF. So that's the true shape, TS for true shape. Now the question asked us to get the true angle between AB and BF. So it's the angle at B they're looking for, so I'll just mark that there. That's the angle they're talking about, and just pop in there something like that. And so that's the true shape, and that's the, you could write it down if you wanted, but whoever's correcting is going to know now. That's the true angle between AB and BF. And look, just to be, take it back to where we were, because I do. Okay, I'm going to colour this in green. So that's our ABF in front view, ABF in top view. This is it in an edge view, and that's it there in the true shape, giving us the true angle between them. So that is done. Determine indicate the true length of DP. So the true length of DP we indicated as yes. Plan elevation done. So yeah, I think that's all of 2023 finished. So yes, hopefully that's of use to you. See you later.